Can you see my screen now?
Yes.
Boleh ya? Alright.
Yes.
Okay. So for the last 2 weeks, minggu, we are in a week 3 already. Week 4 dah. Sorry. So meaning to say that we have another 1 or 2 weeks before your test one lah, right? Okay. So we'll try to complete the site investigation topic and then just jump a little bit in a shallow foundation. Okay, so just a glimpse about site investigation, which is you can see this in your mind tab. So this is just a short note from your mind tab. So if you want to highlight ataupun you want to make notes in your mind tab, please do so lah based on the slide presentation ni. Okay, so for site investigation ni, normally it includes planning, which is a program planning. Then you need to have ataupun to prepare test boreholes. Then while doing the boreholes, you can collect your samples, soil sample at certain intervals. This is for the purpose of the in a lab test lah, right? Then of course there's a required minimum depth for each of the boring. That's why I want you to present. Then after this, so at least we can cover all of it at once. Then of course the depth can be changed lah, depending on the subsoil, because we know already it's not that one layer type of soil underneath, and there's different layers of type of soil. So it depends on the boring process, depends on the subsoil that you encounter, right? So for this part, of course, there are certain standard or rules that we can refer to. But as per our textbooks here, Mr. Das and Sivakugan, they preferred or they relies on the rules of the ASCE, American Society of Civil Engineering, which is first is of course to determine the effective stress under the foundation. That's why they want to carry out the site investigation. Then based on that part, so they also want to estimate the variation of the effective stress with that. Yeah, of course, indeed lah, because we want to know those stresses values underneath. Then determine the depth, which is D equals to D1 related to the effective stress. And then of course at the end of it you can use these findings to refer back to your foundation design. Okay. Then number 4 also determine the depth of second layer, the depth of D2. Right, so it depends actually, D1 or D2 depends on the boring stats that you've been carried out ataupun you choose, because of course once you carry out the surface investigation or based on the dust study, you can decide what type of borings or what type of sampling that you want to use. But first thing first, of course, to minimize the budget, and at the same time you want to make sure that you got all the adequate data for your site, right? So for that purposes also, some of the design of the project, you can estimate ataupun you can decide the spacing of boreholes, right? So because some of the engineer, they will ask based on the dust study or surface exploratory by their client, how many boreholes that you want to carry out, what is the spacing for each of the boreholes. So the engineer need to decide, right? So if you refer to table 3.4, let's say you want to design or to construct a multi-story building. So the spacing of the boreholes, this is a future boreholes, so it might be 10 to 30 meter each. But then of course again, it depends on the site surrounding or environment, that how many boreholes is needed. So some of the boreholes maybe just a very not too deep. But then some of the boreholes you need to have, I mean, in terms of the depth, it will be different based on the topography map that you got from the previous process. Right. So then, all right, then we move on to the borings process ataupun borings method, right? So I want group. So group one lah. We can start with group one. You can present your findings, which is I give you around 5 minutes minimum, 10 minutes to maximum lah, for you to present to your friends what is the process of each exploratory borings that have been assigned to your group. Okay, so group one ready?
Yes.
Yes. Okay. So can you share with me the the presentation, whatever it is, because I didn't state slide or video or whatever. It depends on you. Okay.
So, my name is Muhammad Akmal Arif.
Okay.
So today, wait. Okay, so today, I want to share about the solid flat auger. Okay, basically, it is the one of the continuous flat auger. It is the simplest method. Uh, it is the most common method used for advancing borehole. And as you can see on the middle of the presentation, there is the stiff clay formation between the finger and the fish tail. So the size of this boring is available in section 1 to 2 meter. The outside diameter is 66.68 millimeter, 82.55 millimeter, 101.6 millimeter, and lastly 114.3 millimeter. However, this boring possesses some a few disadvantages, such as it is not efficient in loose sandy soil, especially at certain depth. Besides, it can only bore to a maximum width of 24 inches. And lastly, it does not do well below the water table due to water infiltration. Next, I will pass to Ashikin.
Aduh. Okay, how to bore? Firstly, the tip of the auger is attached to the drilling head. This is the drilling head. And then the drilling head provide two motion, which is torque to rotate the auger, and the vertical thrust to push the auger into the soil. And then the cutting bit is placed at the tip of the auger, which is the below of the auger, and the auger is rotated and pushed into the ground by the head and loosen the soil at the bottom of the hole. And then the flight carry the cut the flight carry the cutting to the ground surface, and the auger is replaced with the sampling tool, which consists of the hollow tube to collect the sample. Uh, the sampling tool is replaced with is replace the auger, and the sampling tool will lower it to the bottom of the boring and push into the soil. Then the rod is twisted and twisted to shear off the bottom of the sample, and the sample is stored for later analysis. As we can see at this figure, actually the auger has two cutter, which is finger and fishtail. Fishtail is more suitable for stiff clay formation, and the fingers is uh, can be used for hard clay formation or embedded rock or cemented layers. I think that's all from us. Thank you.
Okay, so any question from group 6 to group 1?
So
Group
far,
6.
okay, doctor.
So far okay, eh? So you know how to in brief how to use the solid fight auger, eh?
Yes.
Nanti pergi internship, after this you know people don't bluff you kan, ini solid fight auger, ini hollow stem auger, right? So
Sure.
from other members, no. Alright then, so yeah, Muhammad.
No, doctor, no, doctor.
There, all right. So then we move on to the group 2, hollow stem auger.
Okay, okay.
Mana you can share? Yes.
Can I start now, doctor?
Yes, please.
Okay, Assalamualaikum and good morning to doctor and everyone. We are from group 2 presenting about hollow stem auger. Before we start, I would like to introduce myself. My name is Taufik bin Azman and my entry number is 197975. The hollow stem auger is one of the most effective and efficient drilling and soil sampling methods, as it can easily drill into glacial till, silt, clay, and sandy soils. It is an exploratory boring category in which the drilling is done to prospect or explore only. Samples are recovered from the soil brought up by the augers are usually badly disturbed and are useful for identification purpose only. From the right picture, it has two parts. One is the outer component, which consists of hollow auger section, hollow auger cap, and drive cap. And the other is inner component, which is consists of pilot assembly, center rod column, and rod to cap adapter.
Okay, so my name is Haris Daniel. My matrix number is 198357. So for the function for hollow stem auger is hollow stem auger usually used for both geotechnical and environmental soil sampling, and then it also used for groundwater monitoring and well installation. Also for the hollow stem auger method is considered as drilling because this method does not need any fluids to advance the borehole in unstable formations. So I'll pass to Nuril for how it works.
Thank you, Harit. My name is Harit, and I'll explain how it works. The video, Harit. Okay. First, the rig is positioned over the location where we wish to drill, and then the auger is rotated and pushed into the ground by the drill head. After reaching the desired depth, the center drill is detached and removed from the auger, and then the auger remains in the hole to support the soil. Then the soil sample is collected through the hollow stem. As you can see in the video, the sample is being retracted out, but the hole, the auger hole, is inside the land to support the soil. I'll pass to the next presenter.
So basically, this method allows for quick sampling since there is no need to remove the auger first. It also allows for non-contaminated samplings in formations of non-consolidated soils. It features a rapid drilling into clay-filled soils, which is easy and cost-effective.
Okay, next we'll go to the disadvantages. So the disadvantages of hollow stem auger is that the auger can only works well in softer material. So this kind of drilling works best in soft to stiff soil at a shallow depth. So it also cannot penetrate rock or other highly consolidated layer. And it is not effective when boulders or large cobblestone or a large consolidated igneous rock formation are encountered under the soil. Next, the auger also have a depth limitation, which is limited to 150 feet or 45 meter or less. And lastly, this method is slower than many other drilling option. That's all from us. Thank you.
Okay then, thank you. Very interesting presentation then. So question from group 7 to group 2. Group 7.
So far, no, doctor.
No,
So far,
Anjali?
so good.
So far so good. So from other member? Ni macam apa? Sedangnya di other group hantar wakil je yang menanya, yang memberi komen. Other member? You want to ask anything about the hollow steam organ? No, you want to know that how many person in charge, or is it just only the driver on the truck, one person only? No?
No, doctor.
Harith pun tak nak komen eh. Alright then, so sorry Harith.
It's Sudana, doctor.
But anyway, it's a very interesting presentation lah. Okay, thank you very much. So we move on to group 3 then. Group 3, wash boring.
Nazri?
Yes, doctor.
Yeah.
Waiting for Nazri to present the
Nazu
Nazri.
Nazri. Okay then.
Assalamualaikum and hi, my name is Muhammad Nazri bin Wat Yama. So today I'm going to present about the wash boring. Wait, doctor. Okay, wash boring is a method for advancing borehole for site exploration and geotechnical investigation in most type of soil except gravels and boulders. So basically, wash boring are the method that are doing for just soil, not for the rock or gravels. The method is fast and simple to carry out and utilize inexpensive, easily portable and drilling equipment. The function of wash boring is to collect disturbed and undisturbed sample in almost all type of soil except rocks. Of the hole. This is where the process of the wash boring, we take the water and then we analyze the color of the water. Is it it's going to be different in every water level? Then the third function is to indicate the change in the soil strata by the change of color in the wash water. Yeah, this is what I told earlier. Okay, next, how it works. Firstly, the soil inside the casing is removed by chopping a bit attached to a drilling rod. So basically, as you can see from my cursor, the soil that inside the case are going to be removed. at velocity through the hole at the bottom of the chopping bed. And then the water chops soil particularized in the drill hole and the overflow at the top of the casing through a T connection. And then the wash water that are inside are going to collect it in a container, and the casing can be extended with the additional pieces as the borehole progresses, but it's not required if the borehole will stay open and not cave in. Therefore, when the wash water is collected inside the container or maybe a tap, the wash water is gonna have like different color, and then we can analyze whether we can analyze the type or maybe how the strata, and then yeah, the washboarding are rarely used now in US and other developed countries. This is like the boring that are mostly used is like the first one, the first group present. Okay, the advantages of washboarding is that they are light and inexpensive. Other than that, it can also be adopted in inaccessible location. It's also the simplest and fastest method of soil exploration in soft to medium stiff cohesive soil and in sand or gravel without boulders. Hello.
Nazri je kan yang present.
Besides that, it also undisturbed soil sampling. Yeah.
Oh, is it? You wakil you punya group lah nak? Oh, okay lah.
It's also undisturbed soil sampling or field testing such as SPT or venture tests that can be readily done in this method. For the disadvantages, the method is very slow in the stiffer or coarse grained soil, and it's not very efficient in materials such as hard or cement soil, rock and soil, which is I told earlier that this process is not very suitable for the rocks and sedimentation. And then this method also are not stable for collecting the undisturbed soil sample above GWT, since the drilling fluid enters the soil mass, which is it may increase the water content. That's all from me. Thank you.
Okay, thank you Nazri. So your members ada nak tambah apa-apa about washboarding ni?
Basically, Nazri just take our part as well. I don't know why. Are you Nazri?
Nazri main baca je, explain je.
Sorry,
tak ingat dah kawan-kawan tertinggal ke tapi.
Diorang suruh saya baca semua.
Ya ke? Alright. Tak apa. Nanti boleh tambah lah. Nurul nak tambah apa sikit?
Yes, Nurul nak tambah apa?
Nothing. It's okay.
Alright. So thank you. You have three slides at the end, right? Talking about washboarding,
Yes.
Right. So group A, do you want to ask anything about washboarding from group 3? Group A.
So far, no. Very
so far,
clear.
no, Very clear. Is it, Bun?
Yes, I think so.
Alhamdulillah. Because it represents all of those advantage, disadvantage, etc. All right. Okay then. So thank you. We move on to group 4 then. Rotary drilling. Group 4?
Yes, Doctor.
Okay, Danish. Yeah.
I'm presenting.
Okay, you can start.
Start.
Assalamualaikum and Good morning, Dr. and to all my friends. So we are from Group 4. We will present about rotary drilling. So my name is Amirul Daniel Benjasmi, with metric number 19143. So what is rotary drilling? The function is to form a deep observation borehole and obtaining representative samples of rocks. And in a short form, we can say it will use to make a borehole and get a sample of rocks. And then the method used is involves a power rotary cutting head on the end of shaft driven into the ground as it rotates. And the system requires lubrication like air, water, or drilling mud to keep the cutting head cool. And that's what I will pass to my members.
Okay, Assalamualaikum and hi everyone. My name is Muhammad Bin Rashid with metric number of 197348. So today I would like to explain about how does rotary drilling work. So first of all, the rotary drilling can be used in sand, clay and rocks. So it is always necessary to use either air or drilling fluids to reduce the friction on the drilling bit. Furthermore, it is also important to cool the borehole to ensure the drill can continue to run flawlessly and mitigate any risk of the process going wrong. The second one is water or drilling mud is forced down the drilling roads to the pits and the return flow forces the cuttings to the surface. How does it rotate? So by the high level of torque and rotation are utilized by the rotary drilling rigs. So when the soil samples are needed, the drilling rod is raised and the drilling bit is replaced by a sampler. So if you want to have some soil samples, we need to use sampler to obtain it. So I would like to pass to my friend to explain about his part.
So for the pros and cons of rotary drilling, okay, first of all, we move on to the advantages. The first advantage is rotary drilling able to produce incredibly high integrity result and high accuracy. And then rotary drilling also rotary drilling is faster and quicker compared to other conventional drilling method. And it also flexible rig with ease setup to transport from a place to another place. And lastly, it can produce minimal amount of sound that can be evaporator friendly.
So, Assalamualaikum. My name is Al-Faiz. I will continue with this advantage of using rotary drilling. The first one is poor wall protection. Due to the fast drilling speed of rotary drilling rig, it is mainly used to drill through the cutting soil, especially in the land filling and soft soil layer. The hole and shrinkage are easy to occur and should be given attention. And the second one is easy to generate negative pressure inside the hole in the soft soil. It's easy to make a shrinkage. And the last one is uneconomical for holes less than 10 centimeters diameter. That's all.
Okay then, thank you Group 4. So Group 9, do you
Not
have
yet,
any
Doctor,
question?
not yet.
Oh, ya ke? Not yet. sorry. Okay then, continue.
That's all from Faiz, but not yet.
Okay, continue.
So I will explain on the fully case drilling with rotary drive. So for the first one is the casing installation with the rotary drive of the drill rig pushing and rotating into the soil. The second one is drilling with bucket, auger or core barrel. So we stabilize the wall of the bore with segmental casings. The third one is to install reinforcement cage with the auxiliary winch of the drill rig into the borehole temporarily stabilized by the casing. The fourth one is to pour concrete through the trimmy pipe into the case borehole. And the last one is to extract the casing with the rotary drive during concreting. So that's all from us. Thank you.
Okay then, right. So I thought you want to show a video. This is step by step. Fully drilling punya ni case punya ni, right? Okay, so Group 9 open. Any question? One question. Group 9.
I have a question like the rotary drilling method, is it used for deep foundation or like very deep foundation? Is it?
Okay, who want to answer that?
Can you
Group
repeat the
member
question, please?
Yeah, I mean, the rotary drilling process, is it used for like very deep foundation, very deep foundation? Yeah.
Yes, ma'am.
Yeah, who can answer that?
Yes, it is.
Okay.
Okay, thank you.
All right.
Okay. So any other question?
Hello,
Yeah.
I want to ask
Proceed.
what is the limitation of the drilling depth?
Oh, very interesting question. How deep is it?
Yes, how that is it?
Oh, depth. For what you found, the drilling depth for this method is 203 to 445 millimeter.
Millimeter?
Millimeter.
Milli?
Oh, diameter.
The depth of the sampling. Apa yang casing tu tadi? Siapa yang last present tadi? Muhammad. About the fully case drilling tu. Tu boleh jawab tu soalan tu. How deep is it? So for all of you, we are talking about this boring part, which is the process to get the sample, or the process to get the view of underneath. So it doesn't matter for the deep foundation, shallow foundation, but then of course the extent that we want to make sure that, of course, we want to make sure that we have all the data that is needed for any type of foundation, right? So that's why we call it exploratory. And we want to investigate, we want to explore by using these different methods. So how deep is this for this one? Because as far as we know, supposed to, there will be a varied depth for each of the methods. That's why as an engineer, you need to decide which one is the best for your site. And based on your topography punya map, based on the you punya surrounding, the environment that you've done before. So it's okay. Just try to figure out the depth for each of the methods. Right. So we move on to the last one for the borings part, group 5. Thank you. So group 5, question.
Hi everyone. Group 5. Hi everyone. Sekejap.
Najwa nak share.
I want to share a video about percussion drilling. Boleh dengar ke suara? Okay. So as you can see from this video, here is on the top side of this percussion on this drill. It is a heavy steel attached to a rope which is lifted either by hand or by usually by a machine lah. Old times they use hands. Okay, let me play the video. So then the water is enter to the hole so that it makes the mic out of the. you guys can see, the steel is pounding to the hole so that the what is called the baler is then move slowly down to the hole so that it collect the mud of the soil. So that the soil will come out from this steel, and it will repeatedly until the hole is clear. Yeah. Okay, so here is the percussion drilling. So working of percussion drilling as from the video is first the heavy steel is attached to the rope, which is lifted either by hand or machine, is then dropped to the cut to cut the earth, and then chop the earth. The water is added to the well, so the pit makes mud out of the earth it has cut. And where does it usually work? The manual percussion is suitable for drilling in consolidate formation like sand, silt, stiff clay, gravel, sandstone, laterite, and weather rock. So I will pass to other for advantage and disadvantages of this percussion drilling.
Okay, for the advantages of the percussion drilling, it's simple to operate and maintain, as it will require the simple apparatus tools. Second, is suitable for a wide variety of rocks, as it can chop in through the rock. So third, the operational is possible above and below the water table, and it also possible to drill into the considerable depth, which is 30 to 250 feet. For the disadvantages, this percussion drilling is slow method compared with the other conventional drilling. This equipment can be heavy and expensive. The problem will occur when the dealing with the unstable rock formation, and lastly, water is needed for dry hole to.
Ya, Hanis?
That's all for us. Thank you. Okay.
Oh, okay. Right, so dah habis Najwa dengan Anis je present. Yang lain-lain ada nak tambah? Tak ada. Okay, so group 10, okay, thank you. Group 10, ada apa-apa nak tanya? About percussion drilling. Group 10, saya tak nak panggil nama. Other members? What about other members?
Doctor.
Yes, saya dulu.
The percussion drilling is used for soil sampling or just for foundation?
Two different things tu. Najwa, Hanis nak jawab?
I think it is for foundation only because tak ada because foundation only. I think.
Siapa? No.
Hello, can you hear me?
Yeah. Continue.
Okay, so from our research,
Wah, dia cakap-cakap belakang.
sorry, Doctor. The percussion drilling, first, the purpose is to obtain a hole, like Najwa said just now. And another purpose is to take out soil sample and evaluate the subsurface condition. So maybe we can use for the both purposes. Am I right, Doctor?
What about others? Any comments? For those who had this sharing session about the boring methods ni, different methods ni.
I think
Muhammad.
Yeah.
I think I agree with her.
You agree with Mimi?
Yes.
Tadi Nurul tanya, is it for sampling ataupun untuk foundation? Which is untuk foundation tu I tak clear sangat sebenarnya, tapi I know the thing is you want to know is this we want to prepare for the foundation punya hole ke, nak masukkan piling ke apa, something like that, Nurul?
Yes, Doctor.
Right.
Oh.
So
I'm not sure, Doctor.
Just bear in your mind, we're still in the exploratory punya parts, which is we want to explore the site, isn't it? Just bear in mind like that, right? So meaning to say that, of course, one thing for sure, you need to prepare a boreholes, isn't it?
Yes.
You nak prepare boreholes tu, you kena drill, isn't it? So this is the method that we discuss. We are drilling the holes to preparing the boreholes ni. Nak buat lubang, nak cari sampel, nak dapatkan the idea or the what do you call that? To explore, to get the data. Not yet data tu, nanti bila dah ambil sampel, you want to carry out those tests in the labs. Baru dapat data, raw data, then after that you want to analyze. Then you can move on to preparing the design of your piling ataupun preparing the design for your shallow foundation, the footing. Okay? We are moving forward. We are moving towards that. No worries. Alright? So any other question? This is the final dah ni yang berkaitan dengan borings. After this you want to go to soil sampling punya parts. No?
Doctor, how can the soil sample be taken? Because from the video we can see that the soil is very watery. So how can we collect the sample?
We want to know your friends punya presentation after this. So this part, just only to make sure that you have the borehole. Kan? Yang tadi memang memang you nampak water je lah. Memang sebab dia chopping down the earth, isn't it, Najwa?
Yes, betul.
What about other group 1 until group 4? Those drilling method that you just present to us.
I thought the soil from this activity cannot be used as soil sampling because the sample is already wet. But I don't know if it's true or not.
Liquid dah, bukan wet dah tu.
I think it's called slurry, I think.
Yes, kind of slurry. Right. So the thing is actually it is the method that you use water, you use which group tadi sebut drilling mud? Which group? Drilling mud? Is it group 3 Nazri tadi?
Yes, Nazri.
Oh yeah.
And you talk a bit about drilling mud. One of the it is like a material used to make sure that the cutting part of the earth is smooth enough. you nak chopping down those earth layer, and then but then it depends on the what type of layer, kan, which is for the percussion drilling ni is more on soft rock punya layer, and for previous method tu some of it is more on the clay layer, silt layer. So as an engineer you need to know lah which which method is suitable for your site, and you know how to find out your site is contain clay or silt or sand type of soil. Kita dah buat desk study, remember?
Remember.
Okay, right. So, okay, thank you. Since this is the final for the borings part. Okay, so before we move on to the soil sampling parts, just want to share with you a bit about it. Okay, this is also you can find it in your Mindtech parts. Right. So the procedure for sampling soil. Okay? So before this, you talk about the drilling method or the drilling tools that suitable or that available nowadays. But then of course it depends on the budget of your company which part that you want to, which method that you want to use. Then before we move on to the procedure for soil sampling a soil, then you dah buat hole tadi, dah buat lubang tadi. So mean to say that you need to find out a suitable tools also for the sampling purposes, right? So one of the very simple one, we call it test pits ataupun open cuts. Mean to say that okay, you go to your site, then you just use backhoe, bukan excavator tau, backhoe. So you can just dig a small pit, lubang, make it a square pit. Then after that, you can collect either a disturbed sample or undisturbed sample. But then this one is only just a few depth only, like 3 to 6 meters, something like that. Okay? So for disturbed sample and undisturbed sample, there will be different purposes ataupun different lab tests that suitable for it. Okay? So for the disturbed sample, disturbed ni maksud dia terganggu lah. Terganggu meaning to say that it's not that like slurry things macam air tadi, no. Tak macam liquid punya phase, no. Disturbed like you just simply take a shovel, then you you dig a hole, so you disturb lah tu, meaning to say your sample is disturbed, right? So that kind of soil, you can carry out a certain laboratory test, which is the one that you carry out in the soil mechanics too. Okay? Which is first is grain size analysis, which is the particle size analysis. Sieving, shaker, using shaker, apa semua tu kan? Ingat lagi tak? Hello?
Ingat.
Okay, right.
Remember.
Then attribute limit. Attribute limit. Remember how to carry out the test?
Attribute limit yang mana tah?
Attribute limit adalah, what is attribute limit test?
Water content.
Water content.
We need to measure the water content.
Then, in terms of what? Water content in terms of what? What type of test? Liquid and plastic limits.
Yes.
Okay. Combination for both of it, liquid and plastic limit ni, this person attribute limit, attribute say that it is attribute limit. Okay. And then of course we need to find out the water content, right? Because you want to know the limit for each of the state of your sample. Then specific gravity. which is you use the pygnometer bottle yang kecil tu kan? Lagi? You still remember? Pygnome content, classification of soil, which is the index test lah. Right? So this one is based on the disturbed samples, which is you disturb the sample, you dah mix the samples, kind of mix lah, disturb, right? Then of course disturbed samples ni can be used for consolidation, those permeability tests and also the shear strength test, which is this is only you need to find out the undisturbed sample. But of course in the lab we carry out the lab. You carry out the lab, isn't it, for the consolidation, permeameter and shear strength? Do you carry out the lab test?
Yes.
Okay, you pergi tengok je. Or you just watch, okay, sample is already there, so I just take the data, the value. Which one?
We did that. Only for soil mechanics 2.
Yes, saya.
We did that lab.
You carry out the lab kan? Kan? Buat odometer tu, small sample in a ring, isn't it? Kan? So, yang lain semua okay ke tak ni? Everyone's okay? You still can retrieve back your mind masa tu buat lab test and etc. Okay. But then if you still remember those odometer tests, the shear strength test and hydraulic conductivity, especially hydraulic conductivity lah, which is you just go to the panel and then you just measure you timbang untuk hydraulic conductivity test ni.
Doktor, actually waktu tu kita orang online, jadi tak buat lab.
What about video? Sorry?
Tentu macam baru start sikit.
Tapi you sempat kan? Ada yang sempat buat, isn't it?
Sempat yang plastic limit tu.
Only 2-3 labs saja. Yang semua tak sempat.
Oh, is it? What about video then? Have you watched the video? Ada tengok video tak? Video buat testing apa semua. Takkan Dr. Linda tak share dalam YouTube? Okay then, so your...
Maybe tak ingat kot.
Okay, your task now, okay, please watch the video dalam YouTube. Saya pun ada video, just a simple one. Untuk consolidation, untuk hydraulic conductivity. So what about your lab report? You didn't prepare it then? No lah, tak buat. Memang tak ada lah lab ni kiranya?
3 awal tu je dia.
3 awal tu je lah, ya? Alright, okay. No worries. We have another source kan, you can watch the video and based on your presentation just now pun, I know you know how to find it. I mean those videos and etc. So alright, so okay, let gets back to our topic lah, which is so alhamdulillah at least you know how to carry out the plastic limit those specific gravity pun sempat shift analysis shift tak sempat.
Sempat kot.
Apa kot?
Okay, meaning to say that the first week, first 3 weeks tu yang only, betul tak? Terus, alright, as simple as using a shovel. Dah. Tapi for undisturbed sample, there's a few methods ataupun tools yang specifically to get this kind of sample. Okay, so for that purpose, I think maybe we can move to our session, which is for the presentation of soil sampling. from first group is group 6. Okay, so group 6, ready?
Okay,
Alright.
Doctor.
Okay.
So, hi everyone, we are from group 6. Now, Shazwani will share her screen first. Warni. Okay, so first let us watch a video from YouTube. Okay, for this one, this is the hollow split spoon. Okay, so the man just cut the soil. Okay, now we will share our slide presentation. Okay, so briefly about the split spoon sampling is a part of standard penetration test (SPT), just like what everyone can see from the video just now, and it is one of the most popular institute tests carried out worldwide. So the test was developed first at US, and then this split spoon sampler can be used in the field to obtain the soil sample, just like what Doctor said before. But so as you can see at the figure below, that is the standard split spoon sampler. Okay, Wani, next. So the function of the split spoon sampler is to identify and analyze type of soil. Also, it to determine some properties of soil, especially in cohesionless soil, which undisturbed sample that what Dr. said just now, it have few tools to be done to obtain the undisturbed sample. So this one at the figure below, so how the split spoon sampler demonstrate, it just drill in the soil, and yeah, that's the point. So next I will pass to my member.
So next is how it works. So the first one is the split spoon sample is a tube split into two equal half lengthwise. The two halves are locked together during the sampling activities and released to retrieve the samples. At bottom end of the sample sits a driving shoe. This is what cuts into the soil and provides the sample and goes up into the tube. At the other end of the tube is a coupling that allows it to connect to the drilling rod. Once a sample is taken, the operator removes the end from the tube. This allows the tube to split open. And the last one is representative sample can be taken and put into containers for shipping to a lab for analysis, observed and field tested in the field, or discard in a proper waste container if not warranted for the investigation.
So for the advantage of spoon split sampler is it easy to obtain sample in unconsolidated material above 100 feet. And then the second one is it can produce a very Google quality of sample for both lithological and chemical analysis. And lastly, relatively efficient and inexpensive at shallow and intermediate depth. And for the advantage, it needs skilled workers and a very high maintenance.
Okay, that's it.
Yes, that's it.
Okay then. So thank you. Group 1, do you have any question about split spoon sampler?
No, Doctor.
No?
No.
What about other members?
At the moment.
Other members? No.
So no.
No, eh?
Not yet, doctor.
Not yet, eh? All right
I
then.
think they have a question.
Ya, Akmal, apa? Dah, tak ada. Alright. So, okay, this is one of the apa panggil one of the famous lah ataupun yang apa the most that normally used by the contractor to get the disturbed samples, right? So as simple as the showing video tadi kan, as you watch. But then of course it depends on the depth that you want to take your samples, right? So for that purposes actually, if I can share some of the example of the boreholes, the one that you carry out, I mean in terms of you choose the tools to boring, then after that you want to take the samples, right? Okay then, hold on. Can you see this example, boreholes?
Yes.
All right, so this I think is not a new view for you as you watch ataupun as you seen this kind of borehole log. I think in engineering geology you dah tengok kan di sini, right?
Yes.
So right, okay. So this is in 2016 punya ni in our surrounding lah in University Putra Malaysia, which is this is the SI borehole log for cadangan menaik taraf bangunan, which is actually for building for construct a new building surrounding Pusat Kecemerlangan Pendidikan Pertanian, right? Do you know where is it? This Pusat Kecemerlangan Pendidikan Pertanian. Have you been to explore our UPM? You dah tahun 3 kan di sini? Right, so tak apa, nanti cari dalam Google Maps Alright. So for these purposes, if you have a look, I mean in terms of the for the data ataupun the raw data that have been jot down by the contractor ataupun this actually the person in charge for this borehole is the geologist, pakar geologi lah, which is the geologist or the technical engineer geologist that need to know or jot down this part, which is for the purpose of the split spoon sampler tu, they use a SPT pipe, right? Which is if you notice this kind of symbols, this one, this one, this one, this is the SPT ataupun the standard penetration tools have been used, right? Okay, the split spoon sampler have been used in this kind of things to get the sample, right? So, but before that, which is the SPT blow counting also collected, So for this part, for SPT standard penetration test ni, using this blow count ni, if you notice these figures, these numbers 5, 6, 6 until 4 ni, so then you can get the end value, which is the value for the strength of the soil. And then the sample here can be carried out, can be bring to the lab and then carry out those lab necessary lah, right? In order to support the end value or the findings based on the end value. So if you notice, the end value is 20. Okay, so I think Dr. Zainuddin has explained it to you, and some of your maybe you still remember how to get the total of the end value, the number. You still remember how to get it based on this number? No idea? Forgot?
Yes, Doctor, we forgot.
You forgot, right. So actually, if you go through the your friends punya explanation tadi, right? So by using the SPT standard penetration test, then you use a split spoon sampler dalam tu lah, which is those sampler purposes. But then this is we talk about the SPT testing. So to get the 20 value 20 ni, you just need to add only this part, which is for the first 150, 75, this one is, we call it a saddle punya preparation, saddle number, ataupun the preparation step only, right? So then to get the end value, you need to add up the rest of the numbers, the SPT block, which is the second or the second last 150 millimeter, right? So that's why you got 20. Then once you got this number, you can plot lah, SPT plot based on the number of end value versus the depth of your borehole, right? So for this part, if you notice, they got only 3 sampling of soil, and then 3 numbers that based on the SPT numbers lah, which is starting from this part 23 and 5. So based on this, you can refer to reference table in order to analyze what type of the material or the strength for that material. So using this data lah, you can start designing your foundation, either the deep foundation ataupun shallow foundation. So that's why I told you that the subsurface investigation is important, or is the beginning part of the process before you proceed with your design purposes. All right. So for this one, I don't want to talk more about it. But then, of course, you need to go through. You can just go to Google, find any of the site investigation boreholes. Then you can just have a look. There will be a different presentation, but at the end of it, you need to get the end value here. This is important because you want to find out the value for the bearing capacity of your soil. Then after that, you can proceed with the calculation ataupun design of your foundation, right? So for that one, right, under the split spoon sampling tadi lah, which is for the SPT test. So we have a few correlation based on the N numbers, N60 lah, we call it N60. So for the first one is the correlation N60 in cohesive soil. So you know that cohesive soil is actually is more on like clay type of soil. So once you got the N60 numbers based on the previous punya testing, right, for the sampling part, for the borehole things, then you can correlate it with your standard penetration numbers ni, N60 ni, based on the consistency index, which is this one is the Etherberg limit data lah, the consistency index. So for this one, the CI consistency index ni, you can get it from this equation based on the liquid limit, plastic limit, and also the natural moisture content of your samples. Yang tadi you dah dapat sample, you get the sample, retrieve the sample at site, the disturbed sample tadi you bring it to the lab, then you carry out the test, right? Then you got all those data, then you can find out the consistency index, right? Then using that CI value, you can find out the in terms of the compressive, unconfined compression strength, which is the strength of your soil, right? So it is either one lah. Meaning to say that, okay, you got the CI or you got the N60. Then after that, you can estimate, which is based on the value you got it, then you can estimate the strength of your soil. Like this one, let's say your standard penetration number is less than 2. Tadi, if you remember, let's say this one is 20 kan. Let's say kita ambil 20, okay. So 20, if you refer to this table, this is the reference table lah actually. So if it's 20, so it falls in this pipe. With 15 to 30, so it's very stiff. Then you can figure out, okay, this consistent CI index, consistency index ni based on the lab test is around 1 to 1.5, supposed to. Then after that, you can get the approximate strength or UCS strength, which is for the for your soil. So using this QU, the compression strength ni, you can take this value in order to design your shallow foundation ataupun deep foundation. Okay. So for this one, maybe you can estimate lah which type of foundation that you want to propose to your clients for this site, something like that. All right. So that one is the correlation for the N60 in cohesive soil, right? So there's also a few reference that you can find. The correlation for the N60. So the correlation between the N60 to the undrained shear strength. This is based on HARA. Then pre-consolidation pressure, Puhay, main, over consolidation ratio. So this, we call it a mechanical properties or mechanical data. The one that unfortunately you didn't have time to carry out in the lab. You can get it based on the N60 punya value only. So for each of the equation, you can refer to the Mindtech punya your textbook lah. Dalam tu semua ada, right? Those equations related for the correlation. So then we move on to the for the correction of the granular soil. So granular soil such as sand, they need a correction for the N60. So untuk cohesive soil tu tadi tak apalah, you just got the equation, then you just carry out the calculation kan. So for the granular soil, there's a correction because it's affected by the effective overburden pressure. All right. So for this part, you have this equation that can be used in order to correct the value of your N60. Then after that, you can carry out the next calculation. So this one also can be found the details explanation in your Mindtech. This is just if you want to highlight lah dalam you punya Mindtech tadi, you just want to highlight ataupun jot down the small just put a mini notes there and etc. Alright. So for the correction, there's also a few references ataupun a few research have been done. So as Liao and Whitman's ni, they come up with this equation that can be used to correct the N60. This one is for granular soil. So actually the equation is of course, even though it have been established previously, but then we just took a very important equation ataupun a reference, a study reference that reliable to the in general of the granular soil. Sebab kalau kata sebut granular soil ni, even sand, there will be a different type of sand, kan? So that's why if you notice, there's a lot of there's several equation that can be used, but then of course we just pick the best one lah, ataupun the one that commonly used. So you can see also Scampton's relationship, which is they also present the equation that related to the granular soil, seed, pack, Bazara, and then you can refer to table 3.7, which is there's a variation or different value based on each equation, and then you will get the correction of N60 for the granular soil. So saya ambil this table is just half of it. You can view a fully presentation of the presentable table lah, in your Mindtech, right? So there's a few references also lah. So for this part also you can have a look the example 3.1 for how to use those equation which is referred in to find out the N60, the correlation, and also the correction numbers before you use the N60 in your design purposes, right? So for that one, you can go through in example 3.1, all right? Then we have the correlation between N60 with the relative density, which is the DRN. This one is for the granular soil. Of course, again, there's a reference or the referred equation table out by a different studies. So for this part, we got from Kuhei and Main correlation related to the relative density for the granular soil. You can use this equation, right? And then each of the normally you will get the details supposed to in let's say any of the condition of your site, which is the uniformity coefficient of sand, which is this one supposed to you get it from the particle size distribution test, right? Then the this is pre-consolidation pressure, which is you got the data based on the consolidation test or the odometer test, right? So for that one, you can find the relative density, which is the correlation between the N60. Then we have the Meyerhof. Again, they come up, this person come up with a very simple equation here. But then, unfortunately, this one is only for clean and medium fine sand. So again, you need to be very careful if you want to refer to each of the reference equation to be used in your design. Right? I show you this because each of the references you need it in your design before you carry out the to find out the strength of your soil, and then proceed with the bearing capacity calculation of your sample ataupun soil kat your site. Then you can proceed with the design foundation. This is like a what do you call that? A continuous calculation. So that's why I need to show you this type of ataupun different references ataupun different equation come from the different studies. So again, we have Kubrinovsky Ishihara correlation. How many equation dah ni? We talk about for the relation the relative density granular soil. How many of it?
4.
Sampai sini?
3 dah.
Dah 3 kan? Okay. So I don't think you can simply remember like that. No, kan? But then of course if it's come up with the, of course you are concerned more on final exam ataupun test lah ni kan, it will be given up ataupun you are free to refer to. But then of course again it goes back to your case study. ataupun goes back to your question, which one is the best equation that you want to use? Right. So this is the number 3, correlation ataupun equation that can be used in order to correlate between N60 and relative density. So the number 4, which is Cohe and main correlation. Again, this is some sort like a modification by adding up some of the talk about the correlation factor for the aging. The aging punya side pun can be counted or can be put in a credit. I mean, in terms of the to find out the relative density of the granular soil. So then we have in terms of the yang tu dah habis dah, the correlation of N60 for the relative density of granular soil. Then we move on to the correlation between angle of friction, which is related to the strength parameters of your soil or samples with the standard penetration number, which is again N60 lah. Standard penetration number N60. Then you can use either PEG punya equation here, right? Ataupun the Schmidt-Mann punya equation, right? So this is again for the angle of friction, Hatanaka and Uchida. They come up with this is if you compare from the previous one, this is the simplest one lah, which is you just need to find the correction of N60, then after that you can just calculate. Then you got the angle of friction, which is approximate angle of friction for your soil sample. But then of course lah, if you are talking about the SPT test ni ataupun the test that to get the N60, the numbers that related to each of the important parameters, there's a few sources of errors, which is first is inadequate cleaning of the borehole. Yeah, of course, if you look at back the explanation from your friends about the boring methods tadi kan, we have a solid a different type of auger, wash boring, drilling, and etc. tu kan. So this part of course can be reflect or affect to the data that you want to get from the borehole, which is not so clean. I mean, about the borehole. Of course, I will talk about dirts, right? Then the careless measurement of the blow count. For some reasons, we didn't point finger to any, but then of course human errors occurs, maybe while counting the blow count kan, dalam for 150 millimeter tadi kan, which one? Sorry, this one again. So you need to count 75 millimeter, berapa counting, blow counts, 75 millimeter again, berapa counting. So maybe there might be some of the errors, okay, less, ataupun it's more than the one that's supposed to. So it will jeopardize your N numbers here. Okay, so if it's affect the N numbers, so everything that we just talk about to affect lah, right? So then the eccentric hammer strikes on the drill road. This is again human errors and the tools errors. Then the inadequate maintenance of water head in the boreholes, which is again related to the level of the water in the borehole. Right. So then we move on to the in terms of the modulus of elasticity granular soils. Which is from the Cohe and Main equation. They come up with this equation, which is the relation between the modulus elasticity with the standard penetration number. Right. For this part, for the alpha, which is again you need to know ataupun you need to figure out the type of sand ataupun the type of soil that you countering in the site at the site, which is you can refer to for the fines, sand with fines, you just use number 5 and etc. for that part. Okay, Then you can look at the example 3.2, which is here. I share with you some of the N60 value. Then you need to refer to Peck, Schmertman, and Hatanaka, which is again, this is some sort like the use of the equation that we've been discussed before in order to find out the friction angles estimation lah, ataupun approximate friction angles, right? So for this part, there's you need to correct the N60 number first, get the value here. You got the N60 here. Then using Liao and Whitmany, you got the correction value. Then after that, you move on to the find out the friction angle, which is in a unit degree for each of the equation related. Okay. So for this one, you can no worries. You can have a quick view again in a MindTap or your full textbook. In order to get a brief idea, just want to share with you about the N60 numbers tadi lah, based on the SPT and that split spoon sampler tadi, right? Okay, so then we move on to the next soil sampling, which is group 7. So hopefully based on the one that we discussed, you can highlight ataupun you jot down lah a bit notes in your MindTap punya ni. Right, so group 7, we are waiting for you for scraper bucket soil sampling. Group 7.
Wait, Doctor.
Okay.
Aina? Where's Aina?
Sorry, internet quite slow.
Alright.
Okay, so you Okay, you can start.
Okay, Assalamualaikum. We are from group 7. We'll present the subsurface exploration sampling with a scraper bucket. Before that, the function of the soil exploration is to select type of and depth of the foundation for a given structure. Second, to determine the bearing capacity of the soil of the selected foundation. Third, to investigate the safety of the existing structure. And lastly, to establish groundwater level.
Okay, so next I'm going to introduce about the scraper bucket. So basically, sampling with standard split spoon sampler before, it will become difficult to be used if the soil mixed with the pebbles. All right. So because the pebbles, it prevents the spring core catcher, which we can see what is the spring core catcher from the previous group slide in the figure 3.15. These pebbles, it prevent the spring core catcher from closing, or it can, so that therefore it cannot obtain the soil sample. So how does this scraper bucket works will be further explained by Alia and Africa after this. But basically, the sample that we're going to obtain is this tube sample, which this is might due to the frictions between the soil and the tube. So that's all from me. I'm going to pass it to the Alia and Amira.
So next, I will explain how the scraper buckets work. So first, this scraper bucket sampler consists of a driving point which is attached to its bottom end. So there is a vertical slit in the upper portion of the sample. As the sample is rotated, the scraping of the soil enters the sample through the seal. So when the sample is filled with the scraping, it is lifted. Although the sample is quite disturbed, it is still representative. Not only it can a scraper bucket also can be used for obtain the sample of cohesionless soil below the water table. So that's all from us. Thank you.
Okay, thank you. So any question? Group 2.
Yes, Doctor, we have a question.
Yes, Harry.
Compared to other methods, is this method is cost effective?
Good question. Budget things.
Okay. Okay, Harith. Thank you for the questions. And I'm not sure if this is correct, but then in our opinion, we could not know which one is the most cost effective because all the samplers it have different method how it works and how and what it used for. Like for it used for different conditions, right? Conditions of soil. For example, this scraper bucket it used for the soil that mixed with the pebbles, and after this, the Shelby tubes it used for to obtain the undisturbed soil sample from the clay soil. So we could not know which one is the most cost effective. But basically, if we want to find something that most cost effective sampler is that it must be something that can work on the various conditions of soil. But I'm not sure if that's correct. Yeah, and we could not find much about this scraper bucket information in the Google. So I think that is our answer.
I see. Thank you, Anjali.
Okay then. Yes, correct. Which is, of course, one thing for sure, the one that we want to know is about the budget. But then you just need to go back to the purpose or the objective of your sampling, which is for your site. Let's say, like Anjali just explained, if it contains a lot of tables, so scraper bucket is the best one, right? Something like that, lah. Right? So the budget by hook or by crook, even though it is too expensive to your client, but then she or he got no choice. Still need to use a scraper bucket because the site is like this. You can defend lah, meaning to say as an engineer, at least you know that because the site is contain this type of soil, so this is the best one. Because if you use other methods, yeah, of course you will get the sample, but then it's not as accurate or it's not the best sample that you can get. You can defend it like that. You as an engineer, I need to highlight that. Right. Right. So any other question from other members from group? Any group?
Doctor, I want to ask.
Yeah.
For scraper bucket is actually we cannot find much information about it. Is it because it why macam because it costly or people just use SPT or because we don't find any macam calculation ke scraper bucket.
Sebab saya suruh cari prosedur sahaja. No, actually this is some sort like a variety of sampling lah. At least you know, right. So scraper bucket ni, this is just like a very simple tools ataupun very like I want to say like one of the selection that you can choose based on the type of soil that present at site. Right. So calculation or etc tu, okay, first things that you need to think ataupun yang you should bear in your mind. This is like what we want to retrieve the sample. Mean to say that what type of method that I want to retrieve the sample. But then the sample is contain rocks ataupun there's a soft rock inside it, or my sample is clay or silt. So which one is the best method ataupun best tools? So at least when we have this kind of presentation, you have the idea lah, which is this one is only for this one is only for this one, this one is can use all, so which one is the best lah. And lepas tu baru you can think about the budget, the accessibility of the tools to bring to the site. So this is like we say that we need a program or the management in order to make use all of not all selected methods or the borings that you need to bring at your site. Okay. Right.
Thank you, Doctor.
Okay. So any other question? No? So I think we can move on to group 8 then. Thin wall tube. Group 8.
Can everyone see my screen?
Okay then.
Yes.
Okay, you can proceed.
Good morning, everyone. So we are from Group 8 and we will present about the thin wall tube. So thin wall tube is also known as Shelby tube, where it's made of stainless steel. And this one, the main purpose of it is used to obtain the undisturbed sample from clay soil. And common size used for this Shelby tube is the outside diameter of 50.8 millimeter and also the 76.2 millimeter. So this is the procedure on how it used for sampling. First is attach the sample tube, which is the Shelby tube, to the drill rod, and then lower to the bottom of the borehole, and then push the sample to the soil, and then pull off the soil sample in the tube, and at last seal the end of the tube and also send the sample for lab test. So before we proceed to the next presenter, I will show like the video for the sampling method for this. So there is attaching the dual rope to the Shelby tube. And then the tube is pushed into the soil. Okay, so the sample is like taking out like this. So that's all from my part. So I pass to Yao Wei to continue.
Okay, thank you. So I will continue with the lab test. So the soil sample will use for consolidation test and shear test. Consolidation test is used to determine the settlement of the soil sample, and the shear test is used to determine the shear strength of the soil. And then we will use to calculate area ratio, which the outside diameter and the inside diameter input inside the formula and get the area ratio. This area ratio is used to determine whether the sampling process is good or bad. So that's all from us. Thank you.
Okay then, thank you. So, thin wall tube or Shelby tube. So group 3, do you have any question about it? So you got the same source as Plins put sampler punya video
Yeah, I think so.
The same contractor. Right. Question from group 3? Group Nazri tadi. No?
Doktor.
Tak ada Nadia Tak ada. So from other members?
Also no,
No?
Doctor.
Okay then, so we proceed to piston sampler then. Group 9, please. Okay, thank you. Group 8, Group 9.
Okay, Doctor.
Mana siapa nak share?
Saya.
Adib share.
Yes.
Okay, boleh proceed.
Good morning to everyone. So we are going to present about piston sampler. So I will start my part with the introduction. So my name is Dinesh Kanban Analaki Raman and my meeting number is 1974663. Next slide. For this one, in intro part, I'm going to talk about the characteristic of the piston sampler. The piston sampler is basically a tin wall tube sampler with a piston rod and a modified sampler aid. The sampler, also known as Osterberg and Ursley sampler, is particularly used for sampling soft soils where sample recovery is often difficult, although it can also be used in stiff soils. The piston sampler is suitable for sampling moderately corrosive soils below the groundwater level, sand soft soil layers, both in auger holes and in open water. Next one is the piston sampler set is standard suitable for sampling to a depth of 5 meters. The samples are hardly disturbed. Their length equals to operational depth of the piston sampler used. The Edelman aggregate is suitable for augering down to a moderate cohesive soil layer below the groundwater level. The spiral auger can be used to remove gem sample material from a piston sampler. So one of the example is pitcher tube sampler. Right. So next I pass to Azmil.
Thank you, Adib. So for the technical specification, there are 3 types of auger type. First is simple piston sampler. Second, Edelman auger combination type, and third is spiral auger. So for the single piston sampler, the diameter of the tube is basically 38 times 40 mm diameter, and the overall is basically 60 millimeter. So for the dimension, the operational length basically is the length is 1965 millimeter, and the tube length, the total of the tube length is 2000 millimeter. So for the material, the uses of for the material of the single piston sampler is basically stainless steel. So for the Edelman auger, so the diameter is 70 millimeter. The dimension of the blade width is 35 millimeter, and the material used are iron manganese steel. And for the spiral auger, its diameter is 30 millimeter. For the dimension, I didn't find, and the material is iron manganese steel. So next, I will pass to Kavi. Ishmam, sorry.
Okay, Assalamualaikum. For the piston sampler, as you can see, here is the instrument and there are some numbers. So the number 1 is the bayonet connection. The second one is the wire eye. Third one is the opening. Fourth is the stainless steel tube. Fifth is the steel extension rod, and sixth is the piston. Okay, for the steps, at first we attach a polyester cord to the piston sampler's wire eye, and we let the extended auger down to the bottom of the augered hole. Okay, the extension rod should remain in the lowest position. By shaking the extension rod, it will fall to its lowest position. Okay, now what we will do, we will pull the cord which is attached to the wire eye of the extension rod to hoist the piston, and an under pressure will be created below the piston. So we push the tube steadily down at the same time. So we will keep the cord and the piston stationary at a constant distance to the sample material. So what will happen if we press down the tube, it may cause resistance, and then the small pulling movements of the cord will actually increase an under pressure, which will reduce the resistance and disturbance of the sample. Okay, when the tube is filled up, we will push once more and we will put it out of the auger hole. To keep the sample in the tube, the piston should remain in the highest position by keeping the cord taut. A suggestion is to tie the cord with the handle. So we will keep the extension rod parallel with the auger rod to prevent the piston to leak, and consequently it will cause loss of the sample. Okay, if there is any difference in the height of between the water level in the auger hole and the ground surface, I mean, if it is too large, then the sample may fall out of the tube. So the suggestion is to fill the auger hole with water. Okay, and at last we will place the sampler horizontally on the surface, and we will push the sample out of the tube with the piston while drawing the sampler towards, and we can use a gutter to collect the sample material. And the shaking of the tube, it can facilitate us in this process. Okay, for the next step, for the next slide, I will pass it to next presenter.
Thank you, Ishmam. My name is Kavian, matrix number 193960. So for the application of piston sampler, the piston sampler is particularly suitable for general soil research and also environmental and hydrological research. And it's also useful to get sampling in conjunction with baler boring and also for wet decontamination. That's all from our group. Thank you, Doctor.
Okay then, thank you. Right. Wow, this is interesting. Piston sampler can be used also for the for environmental and hydrological research. Okay. Right. So, question from group 4 to group 9, piston sampler. Mana tadi? Amirul, Al-Faiz?
Satu.
Tak ada? Dah hilang ya?
Habis.
Okay, from other members, any question? Sorry?
So far, no.
Yeah, Muhammad? So far, no Alright, okay. It's not so far, no lah. Dah habis dah pun. Right. So for this part, we just left only one for soil sampling, which is group 10, direct push sampler. So thank you, group 9.
Thank you, Doctor.
Thank you, Doctor. Alright.
Thank you, Doctor.
Okay. So group 10.
Kok ni tadi telefon adik.
Yes, Doctor.
Yes, please share your presentation.
Tak mahu mengganggu. Nanti kalau hang tak boleh berjawab, hang cakap kat abang. Oh, akak Mira tu dia tipu adik waktu adik tengah
Okay, you can start.
Mestilah.
Akak dah tahu dah perangai hidup Lepas tu lah akak cakap, okey tak boleh. Nanti dia akan pun dia jadi kealasan macam gitu.
Mestilah.
Bosan ke kelas tu lah?
Ni presentation student yang present.
Oh, student yang present. Yang seorang perempuan ni seorang siapa? Cikgu?
Hello. Kuat sikit. Hello.
Lecturer adik dah bagi. Adik dah present dah. Adik group first, okay?
Tak apa. Patutlah dia tak fokus sebab hang kedal.
Ikhwan
Tapi dia bukanlah dia bukan present apa pun, dia macam present yang ni je kita bagi macam cara-cara nak ambil.
Saya dengar suara-suara lain pula.
For the introduction, the direct push sampling is a process of using direct push technology to collect the soil, groundwater, and the soil gas sample. It can recover the continuous soil course to the holes fairly large in the soil itself, and the absorption of the cutting and the ability to recover the course using the relative system and easily mobile machinery.
Kau abang kat Mamu kata adik nak balik kau?
And tools for the soil sampling.
Tak, Mamu telefon kan adik telefon Mamu marin lah. Mak kata, oh Kak Mira kata kok ni adik dah lah tak tahu lagi. Dek mak betul lah dia nak balik. Sebab Mamu macam berharap adik balik.
Kata dia nak tak balik sebab nak berubat. Mak kata 3 bulan dia nak balik kan. Lepas tu kan Mama kata apa? Oi, bodoh lah. Mama banyak lawan.
Tu tak apa. Mama telefon adik. Mama macam berharap adik balik.
Lepas tu kan kakak pula Mama kata apa? Mama cik tanya kak bila nak balik? Kak bila nak balik? Kak tak pernah jawab apa.
Kau tak tahu kau mak rindu tu. Mak bosan duk sorang-sorang.
Lepas tu aku nak buat macam mana? Nampak masuk lagi lah tak tahu nak buat macam mana sebabnya. Sebab apa? Yalah orang yang kat aku pun tak ambil resa sekarang.
Ambil otak kau nak ambil kata apa?
Nak ambil rasa beza tu. Kita mampu beza.
Usahakan depo ni tak
Okay, so I continue the presentation. Before that, my name is Muhammad Firdaus bin Samsudin. My matrix number is 19700. Basically,
dah lah celah-celah tu lah nak
there is two type, and one of it was the single tube sampler. So the first point is use single routes. As you can see the figure below, casing to advance the sampler into the subsurface. Samples are recovered incrementally as the boring is advanced. This method is efficient for the shallow application, less than 20 feet, approximately 6 meter. Closed piston single tube sampler provide high integrity samples in most forming condition. By looking at the figure, you can see the sampling sequence of a single tube soil sample. The sample barrel is advanced through the open borehole to succeeding depth. Next, yeah.
For the dual tube sampler, it is utilized concentrate casing to advance the boring. The outer casing remains in place as the inner casing is used to chip out the sample as the boring is advanced incrementally. Like the figure show, the outer casing prevents borehole collapse and generally reduces the potential for cross-contamination between sampling intervals. Unfortunately, dual tube methods are subject to formation heat when sampling in saturated sand. Under this condition, water must be added to the outer casing as the samples are removed to prevent fluidized formation from entering the outer casing through the open partition as the sample is retrieved. Formation heat will complicate and retard the dual tube sampling process. Under these formation conditions, a closed piston single tube sampler will provide higher integrity samples more efficiently. All sample contact treatment should be appropriately decontaminated between samples and locations. All boring should be properly grouted and abandoned.
Lepas tu kalau balik Kedah ke, biasanya balik Kedah tak banyak barang kan. Tapi kalau balik Terengganu,
That's all? Finish for all the group?
banyak kilo balik barang kan. Sebab barang-barang Tupperware lah apa semua yang masak kan.
Yes, doctor.
Okay then. Alright, thank you. So I open any question, group 5, you want to ask about the direct push sampler?
Lagi banyak.
Faham.
Sebab tu yang kami nak beli, sebab tu nak beli beza. Tapi
Najwa,
Mama tak
Anis?
agree aku nak beli beza. Mama macam
No?
aku mesti kan nak ambil beza.
So what about other members?
Mama macam nak ambil resan lain lah.
No, doctor. No? Okay. Semua no je. This is for what? This is for the soft soil? The hard soil?
Banyak sangat kau kata kalau kau ambil dia, lepas tu dapat kunci rumah, so kereta duduk bawah garaj, kami pun duduk dalam rumah tak pergi mana-mana duduk dia.
Makan apa masuk kat taman.
Kat taman yang apa dekat taman tak makan telur dengan.
Okay then, so there's no other question. So you want a break?
Aku tak cakap cantik lah kat Mama. Lepas tu Mama kata, tak apalah ikut akak lah. Sebabnya kalau macam banyak.
Yeah, so I gave you 10 minutes break. Then after that, we'll continue with some of the slides lah. Alright? So thank you to you all. Jangan left group lah. Okay, so 10 minutes break. Okay?
Alright, thank you, Doctor.
Okay.
kan, sebulan dalam 500 berapa belah ya, sama.
Beza.
Murah lah sikit compare tu kalau nak ambil kereta lain.
Faham.
Macam tu pun cakap macam tu lah kat mama. Lepas tu mama pun macam, tak apa lah, ikut lah mau cakap.
Faham.
Tak tak cakap lah kat Abah hari tu. Tapi Abah tak cakap apa. Kat Usna kan. Kat Usna kan bila dia nak beli kereta, dia nak beli ni sekali kan Abah tak bagi kan. Lepas tu bila akak dah cakap tu nak beli kereta, Abah tak kata apa pun.
Mungkin kau kerja analyst 3 kot. Abah kata pandai dah budak ni kira duit ni, pandai-pandai dia lah.
Lepas tu akak pun macam akak pun, Abah ni tak apa pula kat akak. Tapi akak rasa sebab apa tau. Sebab Kak Usna Han kadang-kadang kan dia duduk cerita kata macam rumah janji nak bayar dengan banding separuh-separuh tapi tak banyak lah kat situ kan.
Betul ke banding tak banyak lah?
Tak tahu lah, pernah dulu dia suruh macam dia kata dia kan suruh ada suruh juga kita duit dengan mama.
Betul ya?
Sama. Lepas tu akak rasa mungkin sebab macam tu kot, maksud dia mama macam akak dengan Wan punya style macam akak dengan mama dengan apa, maksud dia kata combine duit tu.
Tak, dia tak rasa macam tu. Dia rasa sebab gaji kau baru naik yang 800.
Kan?
Betul. Sebab kalau macam memang bukanlah macam Kak Omna kan settle gaji dia ni ongkos 100 lebih ke 200 ya. Gaji kau settle tiap tahun kan nak macam tahun ni saja pun 800 kan. Faham? So macam abang macam tak risau sangat lah sebab gaji kau tiap tahun tu naik banyak juga. Faham? Macam kalau kerajaan tu macam maintain lah contoh RM225 ke apa naik banyak tu lah tiap tahun kan.
Tapi akak pun tak banyak kan, banyak pun dia dalam 300.
Tapi macam tu lah dia sebab tu lah kot abang macam macam apa ni macam
akak pun tapi mungkin juga lah macam tu sebab tapi abang pun tak kata kot sebab akak kan nak buat apa nak beli apa kan abang tak nak buat apa kan. Sebab nak tanya abang pula apa. Lepas tu apa nama tapi abang tak suka apa pula tak apa. Abang tak kata tak boleh lah, abang tak kata apa lah, abang tak kata tak abang bukan abang tak kata apa lah. Abang pun macam
dia asal sebab lagi satu ni sama kot. Lagi satu sebab apa macam kereta pun macam perluan juga. Faham? Macam Kak Ona tu dia nak beli kereta tu sebab balik pun dah ada kereta besar dah. Faham? So dia bukan satu keperluan lah. Macam tu. Dia asal lah.
Mungkin juga. Tapi macam akak pun macam okey je lah. Akak pun sebelum akak tak risau. Akak tahu macam susul dengan Wan kan. Benda yang lepas kan ni sebabnya sekarang macam Wan punya kewangan tak ikut dia main tu.
Dia anak tu?
Dia main tu lah abang sebulan 500. Tapi sebabnya tu akan dalam bulan 10 kan. Lepas tu kalau kat dia agak kat dia besar nak OT kali-kali sikit kat bulan ni.
Dia
kasut kawan dia OT sampai berapa jam? 10 bulan. Kawan dia macam masuk duduk di desa Angkasa tu kan, duduk bilik ni satu orang tu kan. So kerja dia tak ada buat kerja lain. Dia OT sebulan tu apa? OT sampai 70 jam. OT saja seminggu ni.
OT sampai tak ingat dunia. Itu sebab dia tak ada live. Tak apa lah OT lagu tu. Laki kok tu ada bini nanti nak ada anak kalau OT lagu tu mau berkelahi. Oh, faham.
Automatik memang akan dapat COT 3 sebulan tu memang akan dapat lah.
Oh, faham memang wajib OT.
Wajib OT sebulan selesai sebab banyak syikat.
Faham.
Sehari sejam kena. So, seminggu 5 jam. Sebab dia tak ada OT lah. Kalau buat 10 jam, kalau macam dia tambah macam dia sebut seminggu 10 10 jam maksudnya jadi sebulan 40 jam kan. Tapi dah tak ada nak masuk.
Mahal.
Tak banyak. Tadi saya saya masuk tapi tak mana dalam masuk. Buat. Dan tak ada lah. Cuma ada
Yang banyaknya di OT tu.
banyak tu. Dia kan, macam ni kau. Dia one dan dia besar. 2 juta lah. Sama. Tapi dia tambah elang, tambah uji, tambah performa bonus tu semua kan. Gaji dia sampai macam juta lebih tau. Gaji Asok, basic tinggi, tak tu lah. Tapi bila tolak pasal gaji Asok, dia dapat dalam 3 lah Mama.
Sebab kau tak ada bonus semua tu kan.
Kau tak ada, dia elang kan.
Kau elang tu kau tak ada kan.
Kau tak ada elang. One elang saja dekat kamar tu. Lepas tu dia ada performa bonus tu dia dapat dalam 200 kot. Lepas tu ada OT lagi. Maksudnya OT dia pun kalau dia OT 300 kan. 300 sampai 500 maksudnya OT dengan macam pun dia dah dekat 1000 lebih. So dia macam-macam.
Hari berapa bulan?
15.
Walau lambat lagi.
Kenapa?
Nanya tadi data adik habis.
Data dah habis ke?
Tu pun adik dah, sebenarnya adik dah renew. Adik dah add on kata dah. Add on kan mahal kalau postpaid 5 gig sampai RM20.
Oh, lepas tu?
Lepas tu tadi dah habis lah tu.
Habis tu dah?
Yang 5 gig tu pun habis dah, faham tak?
Memang tak ada internet tu dah tak apa?
Dah wifi dah ya, tak boleh. Sebab awal-awal dulu adik lupa connect wifi. Adik duk macam tengok YouTube kau pun semua tengok guna phone, faham tak?
Oh, faham.
Lepas tu bila sedap-sedap tu dia banyaknya dah habis. Aduh. Sebab lagi pun awal-awal dulu dia macam wifi pun dia bukan problem lah. Dia macam setiap kali nak ni dia kena macam login, faham tak? Dia macam susah sikit. Tak selalu auto connect tapi macam baru-baru ni tak tahu sistem dia jadi macam nak kena login. Tapi lah ni dah okey balik lah kan. Dia macam auto connect balik lah.
Oh, lepas tu dia kata anak punya ni bila?
18 lah. Tak banyak hari dah lah. 3 hari.
Lepas tu tak nak ada banyak tinggi lagi. Banyak tinggi lah.
Banyak ke dok dia? Banyak kot. Dok dia kot.
Oh. Tak banyak tinggi.
Tak tahu, tak ingat. Tak kira adik check balik. Itu adik asal bayar tu sebab hari tu adik asal dia bayar untuk bulan. So, dalam bulan 4 kan. Tak banyak ni lagi adik bayar. 85.
Oh, mahal. Akak kan cakap, akak kan suka pakai Maxis kan? Lepas tu, tapi internet dia tak bonus. Bukan tak bonus. Internet tak laju kan?
Okay, Assalamualaikum.
Internet dia sangat orang kata apa?
Waalaikumsalam.
Alright then, so for this not 1 hour lah. Hopefully I can finish it within the time. So I just want to complete this chapter. So actually you can refer to your mind tab actually. But then of course if you want to make a notes ataupun make highlights in your mind tab, please do so based on the presentation that I want to share. Okay. Right. So thank you again for presenting those. I mean, in terms of the methods and also the tools for subsurface exploratory process, which is of course indeed you need to know that before you continue with the design purposes lah, which is hopefully by next week we'll go on the shallow foundation parts. Alright. But then of course we can I want to complete this one first. Right. So
prepaid nak on internet.
Tak mahal kan?
Since you just listen and maybe just some notes about the explanation based on your friends. So of course, there are several tools or several borrowings that you need to know before you choose the best one that related to your soil, to your site. And but then of course at the end of it, the most important part is about the water table, which is if it's possible I mean in terms of the existence at the sites. So you need to prepare this in terms of the water tables assessment ataupun observation. We call it the observation of the water tables by using a piezometer pun, right? So actually once you do all those borings, dah buat borehole logs apa semua tu, actually you can proceed. One is for the sampling purposes, the second is to come up with the piezometer piezometer holes, which is actually for the observation of the groundwater tables. So of course lah, it is important because you need to know the ups and down of the level for the groundwater table near your site ataupun surrounding your site, because again it relates to the bearing capacity and the settlement for the foundation at site. Then moreover, if it's a groundwater level, it's a very critical one because especially in Malaysia lah, we have the wet season and dry season, which is it change seasonally. So you need to know the water tables level, which is the ups and down, right? Okay, so for this part, which is of course this can be related to your hydraulic conductivity test, which is the permeter test. It is either constant head or the falling head, differed by the type of soil that present or exist at your site. And yang tu pun you tak sempat buat juga kan last year. But then of course you can find out, I mean in YouTube on how to conduct the test. Once you got the samples from your site, you bring it to the lab, then you conduct either constant head or falling head punya permeter test in order to find out the hydraulic conductivity test. But then that one is in the lab, which is you want to find out the behavior ataupun the mechanical properties for the samples. But then at site you can come up with a piezometer, which is you can check the water table using a piezometer code, or you have some of the related equipment, which is some of the contractor they use a chain or a tape into they insert it into the borehole that you just drilling tadi, and then after that you check lah for day one how many meters, day two how many meters, and etc. But then to be more convenient, you can prepare this kind of piezometer, which is you have the boreholes yang you dah drill tadi kan. So you just put a tools like a standpipe here, then after that prepare a cement grout, then this is a filter set, this is sand, and then after that you can check lah the water level at your site. This based on the piezometer things. Then okay, that one is about the observation of water level. Then subsurface exploratory can be proceed also by using the vein shear test, which is this one, straightforward to check the undrained shear strength, which is the CU at site in situ. Right, so purposely for the vein shear test is for the clay soils, or especially for the soft clays lah. We have the rectangular tape vein here, and then also the tapered vein. So the difference is the angle at the end of the vein shear too. Okay, so of course by using the vein shear equipment or test ni, we need to refer to the top ataupun the rotation of the road that relate to the veins tu lah. So the torque that normally used for the vein shear test is 0.1 degree per second. Okay, so the rotation, of course lah, I mean in terms of related to the for the soil digging, okay, which is we try to reduce. We try to make sure that the rotation will induce the failure in soil. Then the maximum torque in order to find the unconfined compression the CU tadi, we can use this equation. Okay, so which is T is torque. Right then. Then for the rectangular veins, which is we have two types tadi kan, which is for the rectangular vein and tapered vein. You can use this referred equation and this one also, which is again you need to find out those parameters before, which is the dimension of your veins before you can use this equation. Okay, so the vein shear test ni they have a few advantages lah, which is first you can make sure the rotation is good enough for your site. Then the most important part for the contractor is the most economical, which is the most on the budget purposes, right? Then give a good result for the soft and medium stiff clay. Even though for the medium stiff clays ni there might be some hiccups, but then still because it's still categorized in the soft soil, so you can use a vein shear test. Then for even better in the sensitive clays, right? So however, there are some errors lah, which is first when you use a vein shear test, you need to make sure that in terms of the calibration of the torque, because it relates to the how you handle the vein shear test. Unfortunately, due to some tools or errors, which is for the vein shear test, is a very poor calibration. Then this part is of course is some sort like a risk that you need to counter, which is damage the veins, which is of course even though you say that okay your site is let's say soft clays, but then not all the layers might be clays part, so maybe there might be 1 meter only for sensitive clays or soft clay, but then the rest of it maybe there's a sand or a soft rock, etc. Then this might be damage the veins. Then if it's not the rotation not properly controlled, so there might be other errors can be used, which is for some reasons this is more on the tools errors, not the human errors. So but then supposed to those technical person who in charge to carry out the vein shear test especially is supposed to they have gone through all those practical punya workshop or etc. lah, because you cannot simply use any other tools like you use a shovel, so especially for this one, because you want to check the shear strength parameters directly at site. Okay, so you can have a look at example 3.3, which is this part is referred to the vein shear test tapered vein. Then they gave you a few values, which is including the dimension and some of the constant that you can use to calculate by using the Jerem's relationship, Morris Williams, which is based on the plasticity index relationship, and C is based on the liquid limit relationship. Then at the end of it, you can find out to determine the pre-consolidation pressure. This equation you can find it in your Mindtech chapter 3. You don't have to worry, just go through it again. Okay, so again, all the answers is provided, so you can refer to any those calculation related, right? Okay, so part sampai D, pre-consolidation, right? Then we move on to the cone penetration test. Okay, so before this is a vein shear test, then we move on to the cone penetration test, or known as a Dutch cone penetration. We have this equipment in our lab, which is the CPT equipment, in order to get the sample and at the same time check the strength of the soil at site. So no boreholes are needed, which is you can simply straightforward use the CPT towards the grounds, which is, if you can see here, there are two types, which is one is mechanical friction cone penetrometer, then the second one is electric friction cone. We have this mechanical friction cone penetrometer in our lab. So hopefully lah, insyaAllah, kalau if you want to proceed with the soil or geotechnical project for your final year project, you can use this one lah if you want to find out those data at site, to retrieve sample and also to find out the strength properties. So for this cone penetration test, CPT, we have a few correlation lah, which is the first one is correlation between the relative density and the cone resistance, QC for sand type of soil. So you can use this equation in order to find out the value for the relative density if you know the cone resistance value, and also the atmospheric pressure ni, this is common lah, right? Then I mean, in terms of that one is the previous one, the common equation. Then we have Cohe and Main equation also to find out the relative density, vertical effective stress value. Okay, so this Cohe and Main, they insert some of the value of the vertical effective stress in order to find out the relative density. The values of QC here, this one is a compressibility factor. You can refer to your type of soil, which is right. So this is Cohe and Main equation. And we have the correlation between the cone resistant and drain friction angle for sand. There are three of it, which is Cohe and Main, which is they come up with this equation based on their research study. Then Richery and also Lee, which is here. For Lee, they referred to the using horizontal effective stress. Then the rest of it is a general approach. Okay. Then correlation between cone resistance and the N60, which is come from the SPT test, the split spoon, using a split spoon sampler tadi kan untuk SPT test. Okay. So this correlation can be found out, using this equation. Then the values for the C and also A, which is here C here, and also A here can be found in these tables related, which is if it's based on the referred investigator lah ataupun researchers. So for those related is based on the how do you use this CPT approach, either for upper limit, lower limit of the ground level, right? So you can use this one. But then of course lah, in terms of the nanti you also concerned about how it appears in the question, if it's to find out the N60, and then you have the cone resistance and etc. But then of course lah, you can refer to this equation, right? Then we have the correlation for the undrained shear strength. This is still under CPT, you jangan confuse, this is still right for undrained shear strength, the CU ni. related with the pre-consolidation pressure and also over-consolidation ratio for CLIS. We can use this equation, which is for the CU determination. Then Main and Campers also provide two equations that related in order to find out the undrained shear strength with the relationship with over consolidation ratio and also the pre-consolidation pressure here. Okay, you can have a look. I mean, example 3.4. Just try test your ni, but then of course lah, as several equation that provided based on the site, so you can just use. So normally kalau kata equation based on the question, which equation that you can use, then it refers back to the one we just described in our previous slide. So here in example 3.4 ni, they just ask please use equation density of the sand. So just check, kan, meaning to say that even though you have a list of your equation ni, kalau your question and let's say test 1 ataupun dalam final exam, in a final exam, they said that use Kuhe and Main for sand purposes in order to find out the relative density. So just use the appropriate one. Okay, so for this one, because I mean in terms of the step by step, you just need to find out the effective stress first lah. Okay, then after that for the QC, which is okay, they just what is the numbers or the values that are related, then you can calculate the relative density. Right, so that's, and also or test that related for this one is pressure meter test, or simply named as a P abbreviation here. Okay. So this is also if it's in situ test. So you have your borehole, then you can use the pressure meter test here, which is the explanation have been talk about the how to use the PMT ni dalam you punya MindTap. So you just read it carefully with the figures related. Then for PMT ni, there's a theory have been used, which is a theory of expansion. I mean, in terms of to find out or to determine the pressure meter modulus, which is the EP of the soil. So you can use this equation. Okay, and normally the Poisson ratios ni we assume to be 0.33. Okay. So for this part, you don't have to worry lah, which is all those volume or dimension is provided in the question. So you just need to find out it. All right. Then we have the dilatometer test, which is this is I mean in terms of again to get the data for the subsurface investigation. So we have the dilatometer test here. And then the explanation of step by step, you can have a look in your MindTap. Maybe you want to highlight lah, which is probe is insert with transmitter gas and electric lines. You can highlight in your MindTaps because there might be some of the question appears. Please explain the procedure of the, let's say, PMT or dilatometer test in order to explain to get the data of the at the subsurface investigation purposes. So for dilatometer test ni also they required how to get the measurements and then the rest of it lah. Okay, so you can have a look. I mean the details of the dilatometer, because this is not a common one we use in Malaysia, But then of course lah, if you have a budget to in future lah, kalau you punya company can afford it, so you can propose this dilatometer test ni kan. Alright, so this is the equation based on the dilatometer test. There are 3 parameters that you can find out by using the test, which is first one is material index, which is you can use this equation. Then you have the stress index, horizontal stress index, then the dilatometer modulus. You can use this equation also. Then some part of it, of course, you need to find out lah, which is for pore water pressure and also the vertical effective stress. So to make it easier, instead of you calculate it, Schmertman 1986 ni he come up with this chart or graph in order to find out the dilatometer modulus. So you have the material index value, then you can get or you can find out the dilatometer modulus. And at the same time, you can determine the nature of the soil and the unit weight of the soil, which is simple here. If it's clay, then if it's hard, so you can find out the unit weight if it's for the clay, and if it's high consistency, and also the rest of it. So you can have a look lah. I mean, this is this chart ataupun graph ni to make your life easier lah compared to the calculation part. Alright. Then the next one is the Iowa borehole shear test, which is this is again to determine the shear strength parameters of the soil at site. So we have this kind of the groove plates at each side of the tools. Then you just need to insert into your boreholes. Once you drill, you have a borehole or something like, right? Then for that one, you can determine the shear strength parameters lah. Then at the same time, you can find out the effective normal stress by using this equation, right? Then there are some of the shear stress failure or the parameter of the small s shear stress failure. You can find out using this equation, right? But then of course you need a dimension for your Iowa borehole test, shear test ni, right? So for this one also, once you got the results, you can plot into this figure or the curve. Then at the same time, you can find out your C and also the friction angle, which is the cohesion and friction angle of your soil. Okay? Then the next one, we have the K-note step blade test, which is K-note ni, if you still remember in your soil mechanics too, right? Which is K-note is the coefficient of at rest earth pressure. Okay, which is this is for the purpose the earth pressure approach. Then you can measure the lateral in situ stress. Then here the statement is saying that the soil disturbance, if you use the step blade test ni, is less than the dilatometer test. Okay, so the procedure of the step blade test ni, you can refer to your mind tab in details. But then of course you can highlight lah based on the presentation, which is first one is the first blade push into the soil, then the second blade push, followed by that first blade. Then it repeats until giving the stress measurement. So it should be like this, which is if you refer to this first blade, second blade, and so on, right? So you can plot this log pressure based on the blade thickness. So for this one, so you can find out the stress of each of the blade based on the blade thickness, right? Then okay, this is a coring of rock. I think this is well explained in engineering geology punya subject, because that subject is focused on the rocks. So we have a rock coring tools, which is here. It is either single tube core or the double tube core. Right. So this is purposely on the rock corings and not for the soil. But then, of course lah, the explanation is nearly similar to the previous sampling punya soil, kan? Right? So for the rock corings ni, if it's by the rock cores obtained by the single tube ni, they say that it can be highly disturbed, and most of the fracture of the rock ni because of the torsion, not the existent fracture. So due to that matters, you need to find out or to determine the recovery ratio based on this equation. So based on this part, so you can proceed with the rock quality designation, which is if you still remember, I cannot share the figure here. If you still remember the rock, the coring of rocks too, in geological lab, and geological lab too, there's a fracture of each of the rock, and some of it got a small fracture, some of it got a large fracture. So based on that, you can measure the one that have no fracture in order to find out the rock quality design. You still remember how do you carry out the test in the geological lab 2 years back? Ingat lagi tak? For the rock quality designation?
Tak ingat lah, Doktor.
Tak ingat? Tak dapat bayangan yang apa rock core tu? The rock tak ingat dalam lab, tak apa, nanti boleh tengok YouTube saya nak kata suruh masuk lab pun tak dapat dah. Right. So for the rock quality designation, which is RQD ni, so once you got the measurement tadi kan, you use this equation, so you got the value, so you can refer to this table lah, which is if it's 0 to 0.25, it's very poor quality, and then if it's 0.9 to 1, so it's excellent quality. So actually the purpose is you want to know the hardness of your rock underneath ni, sebab bila once you know that okay, for a certain depth, let's say 10 meter depth, you counter a rock, let's say granite rock, and then the quality is 1 based on the retrieved sample of rock coring tadi, so it's excellent. So meaning to say that when you design your deep foundation or your pile, then you can estimate lah, until 10 meter, then we can this pile can counter the very quality rock, so you don't have to worry about the fracture or the failure of your foundation of the structure. So that's how we estimate ataupun we use the value of the RQD ni dalam you punya design, right? So then that is the some of the test ataupun direct test ataupun the sampling methods that you can just taking the sample and bring it back to the lab in order to get the data. But then of course at the end of it, as an engineer, you need to prepare a boring also engineer lah, tapi normally kalau kat site is geologist lah, but normally engineer pun also need to go to at site, because you need to assist them on how depth that you want to bore the boreholes, how depth, how many samples that you want to get from the boreholes, and etc., something like that. Then at the end of it, the geologist or the technical assistant need to prepare a boring log, and the one that I shared you before, which is there's a log that you need to attach to the report before you submit to the clients. So for the preparation, the driller or the geologist, they record all the following information lah, which is of course they need to put the name, address, which is the details of the drillers, and then also job description, the number, type, location of boring. So boring which let's say 10 meter, D1, D2, something like that. And then date of boring also need to be jot down. Then subsurface stratification, the elevation of water table, which is based on the piezometer punya apa cone tadi, piezometer cone pula, piezometer borehole tadi kan. Then we have the standard penetration resistance and the depth of the SPT that you've counted yang you dah carry out at site. Then how many samples that you collected, the type of samples, because some of the boreholes or some certain type of soil sampling punya method ni, you do not strict to only one method only. Some of it maybe you use SPT, some of it maybe you use a different method that you just dengar you punya your presentation from your friends tadi kan. So different type of methods of sampling also can be used in one site. It depends on the type of the soil or layers that you counter. Right. And then in case of a rock coring tadi lah macam tadi, if it's counter a rock underneath, so you need to make sure that what is the type of the core bearer used, and then actual length of the coring, then what is the recovery of the rock that you get, and then also at the end of it is the RQD lah. All those pictures or photos need to attach to the boring the report to the report. So this is the example. So if you still remember the one that I've shared you before, this is one of other presentation of the boring log. So this is based on the they have the soil description here and the depth of its right, soil sampling type and number, which is here they got it they highlight soil sample number 1, 2 and etc. Something. Then the N60s here they didn't jot down the numbering, but they just only for the total N60 and etc. And then these comments normally after you carry out the test in the lab, because you need to put it after that those value for the liquid limit, plasticity index and etc. Okay, so this is just example for the boring log. Okay, right. I think in details the explanation they have you can find it in your mind tab. And you can have go through it, but then this is just a summary lah, right? Okay, so then the last one, which is the last method actually. This is a very expensive one, so that's why I put it in the last one. Geophysical exploration. So this one need an expert to carry out the test in order to complete the subsurface exploration topic for today's which is normally a big company they just straightforward go to this methods lah, because they have a lot of budget, so no need those soil sampling. Still SPT is needed, but then maybe not all of the method, which is the one that may be necessary, so they can just exclude it, so they just move on to the geophysical exploration. Right. So for this one, because it is some sort like a non-destructive test, which is using the selective or special method. So normally they use as a preliminary works, which is if it's needed, which is they find there's a rock or there might be some soft rock, or there might be some of the soft soil. So okay, we still need to carry out the SPT or the CPT or the PMT, whatever it is. But then this one, okay, we just want to get a clear view, first clear view, so you can carry out these 3 types of geophysical techniques, which is seismic refraction survey. Then we have cross whole seismic survey, then resistivity survey. Okay, so for seismic refraction survey, which is you can get or obtain the preliminary information, which is based on the thickness of layering. So this method normally use, of course, like waves. So you can have a good information for the preliminary one, for the beginning and starting, for each of the layer by using this wave approach. So the procedures or step-by-step thing, if you can go through your mind tabs, so they explain it in details for each layer, step 1, 2, and 3, something like that, right? Okay. So for the seismic refraction survey ni, we use a wave tadi kan. So the first arrival of disturbance wave ni, of course, it can be recorded by the special equipment. They call it geophones. Then for that one, there are two types of stress wave that can be used lah, which is P waves and S wave, or those called as a plane wave or the shear wave. Then the P wave, of course, travel faster than S wave. This is again, if you still remember your physics subject in your secondary school, this is applied for this method, right? So the velocity of the P waves ni, you can calculate using this equation, which is referred or correlate with the modulus elasticity, and then the unit weight of the soil, and then some of the parameters, which is the Poisson ratios. So this one is the table which is related. Once you complete the seismic refraction survey, you carry out the test at site, then you need to refer to this table in order to check the type of soil or rock that you counted at site. Okay? So it is based on the velocities lah, which is here the P wave velocity. So if it's soil, you encounter soil, so maybe it's around 1,200 until 2,000 something. If it's rock, so it's higher than that. So you can check, okay, if your wave, you calculate your wave, you calculate tadi guna equation, then you counter, okay, it's around 2,000. So maybe you can simply say that, okay, layer number 1 is either sand or dry silt or fine grain. But then if you want to know in details, so you need to carry out those soil sampling methods study, right? That refer to each of the type of soil lah. Kalau for sand, so what type of method that suitable, etc. Okay. Then you can look at the example 3.5. So this is details examples which is covered for the seismic refraction survey. You can refer to the figures, which is the one that counted for that site, right? And then they gave you the distance of the geophone, which is for the once wave reflect back to the so you can, this is the reading that get from the geophone, then the time of first arrival given, right? Sorry. So the first thing first is you need to plot, which is based on the time of first arrival and the distance. Okay, so time here versus the distance. So you can plot the graph here, and normally you will get this pattern, which is there's three straight patterns here. So this is a kind of a best fitted line lah. Okay, you can have a look. You can try your own. Okay, using a graph paper, then you can plot it and then get this point and get the best fitted line. So you plot this part, and then once you get this plotting, so you will have these three straight line segments. Those segments, then you can calculate the segments, which is based on the velocity that appears for each of the segment, which is that segment is referred to the layer. Okay, so for this one, using this time distance punya ni kan, alright, so you can calculate the V1, which is for the top layer is around 228 meter per second. Then you can move on to the segment AB, right? For this AB, and then you got for the value of V2 for the middle layer. Then for the segment BC, which is the third layer, you get this kind of this supposed to lah this value. Then you can compare to this apa table, the one that I've shared you here. So you can check the type of soil or rock based on the P wave velocity, the one that you got it here. Okay, so for this one, this is apa? Alright, sorry. The thickness of layers here, you can use this equation, which is Z1. And then for the Z2, if you notice, nearly the same equation, but then they have extra parameters here, which is TI2, which is here you can get it from the plotting. Okay, for this one. Okay, this one. So the TI2 here, okay, which is from the third layer, third segment, then you can just straight, this is straight 90 degrees, so you got the TI2. Okay, so this is step-by-step things like you don't have to read. Unless you miss the step, then you won't get the answer correctly. Okay, so the rest of it, which is the total of Z1 and Z2, once you got the Z1 and Z2 here, then you have this the rock layers based on that table, it is around 16.60 meter, right? So again, all those steps is explained well enough in the mind tab, right? So that one is the seismic survey, reflection survey. Then we move on to the second geophysical exploration, which is the cross-hole seismic survey. So this is based on the again, the velocity of shear waves. Here, you need to make sure that, in terms of the distance here, is jotted lah, which is because you need it in this equation to find out the velocity of shear waves. So for this part, just simple equation is used. Then for the last one, the resistivity survey, which is in terms of the particularly used, which is purposely used of the resistivity survey for the fine grained soil. So you can use this equation to find out the based on the referred value, and then also the dimension that can be find out in the area. Okay. So this table can be used also as referred to once you got the calculation lah, okay? Dah complete those value and etc. So then you can refer to in terms of the table. If it's sand, then suppose you got the resistivity around 500 to 1500. If it's weathered rock, 1000 to 2500, and if it's sound rock, it's more than 5000. What is sound rock anyway? Is it? Have you heard anywhere about this particular material, sound rock? Tak pernah dengar? Okay, please you find it. What is the sound rock? Weathered rock, you know, supposed to in geological engineering. Okay, so based on the resistivity also you can categorize. It is either if it's low resistivity, then it's saturated clays, and if it's dry soils and so on lah. Okay, so for this part, normally we use a Werner method, which is for the resistivity survey. This is a very common procedure. We use a Werner method. Then the explanation is in MindTab. I don't have to highlight there. You can just go through it. All right. Then last topic for the subsoil exploration, you need to prepare reports. before this you prepare the driller need to give you a boring log. So you as an engineer, you need to prepare a report which includes the description which is for the investigation, right? Then description of the subsoil exploration conduct, which is refer back to the type of methods that you use, the type of drilling that you use. So then also include the description of location of the site, any structure. This is the surface exploratory that you've been carried out before. And then also a geological setting of the site. So then move on to the subsoil exploration, which is the purpose of the number of borings, depth of borings. So this is the one that you need to include in your report lah, right? And then so on, which is again the type of method you use to to get the sampling, to get the soil, what type of the sampling methods that you use, and then is it the use of the piezo cone to get the water table condition, or you use other type of equipment. Then most of all is the type of foundation recommended based on the result. So you as an engineer, you need to know lah, what is the best foundation. Is it shallow? Is it deep foundation? And then if it's you propose like that, why? Based on the result that you got from the subsoil investigation. Then at the end of it is the conclusion and the limitation. This is like a very complete soil report that you need to hand over to your clients. And of course, at the same time, you need to present to them lah. Okay, because of this finding, so we propose this kind of foundation, and due to that type of soil, due to the environment, due to the weather, so some sort like that. Okay. And moreover, in your report also need to be attached is the graphical presentation, which is the map, the geological map, the one that you shared with us in the previous presentation. Then there's a plan view, which is the one that you propose related to the proposed site. Then those boring logs, this is also need to be attached, the laboratory test result, and also if there's any other special graphical presentation also need to be attached to the soil exploratory report. Okay then. So that's it, I think, for the topic of site investigation for this subject. Is there any question? It's 1 o'clock already. Any question? Yay, dah habis. Right, so I need you to, yes, sorry. Ishma? Sir,
Doctor, can we get the slides that you teach us today?
No, because actually the slide is the summary of your mind tap. So actually you can just go through it again. It's the same. It's just the method that I just make it short, you know. So that's why I told you that while I'm explaining during the slide presentation, you can just use your highlight or your notes in your mind tab. So at least you can go through the mind tab platform also, kan? So I won't share this one, right? But then actually it's the same, right?
Okay.
All right. So for your this week task, and maybe you can proceed. You can proceed with the problem statement in chapter 3. Okay, please do it. All those problem statement. Quiz, let it be first. But for problem statement, you can just go through it based on the examples. Actually, all the problem statement. the one that I've shared you, example in chapter 3. Okay, then the rest is I think maybe so next week we'll go on to the next new topics lah. All right. So if you have anything you want to ask, just pop up the question in our WhatsApp group, okay? Or PM me.
Okay, Doctor.
Okay, then so if no any issue or question, not yet, okay? So I think we can dismiss. So have a nice iftar and take care. All right.
Okay, thank you, Doctor. Happy
Doctor.
All right. So assalamualaikum. Bye.
Wassalam.
أشهد أن